So while we're getting the stage set up, everyone think of your questions. We'd like to use the time to jump right into the audience questions.
Well, there's a few people I wouldn't mind sending to the moon right now. Am I right?
So I think we have everyone. Do we have a question ready from the audience?
Thank you so much for your presentations. When you guys were talking about building a colony on Mars, what knowledge would that contribute to saving the Earth and preventing climate change so that we might be able to sustain life on both planets? Thank you.
Well, that's easy enough. So Bruce Murray, I mentioned him earlier, he was the head of JPL, Jet Propulsion Lab, during the Voyager missions in Viking. He used to say all the time, people ask, why are you exploring, in this example, Mars? What are you going to find? We don't know what we're going to find. That's why we're going. And so to me, there's no question, the more we learn about other worlds, the more we'll learn about this one. But I will follow that up with, we are perfectly suited to live on Earth. We are not perfectly suited to live on Mars. But humans end up all over the world, so probably end up all over the solar system. But one more thing, and then I'll hand it off to somebody. You throw out the word colony. Colony's gotten a bad rap anymore. What we want to do is settle another world. Over to you.
I will say that Mars, compared to all the other planets, has actually used to be very similar to Earth. And there were specific geologic events that happened in Mars to make it not like Earth. And the more we understand about what happened there to make Mars the dry, airless planet, the dry, waterless, not as much water, that it is now, the more we can learn about making sure that that doesn't happen here on Earth.
Anyone else like to chime in?
Well, if I may whine and complain. You got somebody else going to say something? I can't see.
Go ahead, Bill, I think.
So I'm all for SpaceX, rocket, Mars, boom. But what
Hopefully no boom.
Well, yeah. Well, most of the time in space, there's no sound. It's just... So, Mike, everything's fine. It's all going to work out. Just don't want to have the interesting places on Mars get messed up landing on Mars in too much of a hurry. Very solvable problem, everybody. Very solvable. Just the question that I want to know, to the deep question that you brought up, where did we come from?
Yeah.
And it's very reasonable. It's extraordinary. It's crazy. But because Mars is smaller than Earth, it cooled off faster, it got an atmosphere faster, it got an ocean, 1 billion years before Earth, something like that?
3 billion.
So is it reasonable that life started on Mars, and then Mars was hit with some sort of impactor, and then fell, except there's no sound, and it landed here on Earth, and then you and I are descendants of Martians. Like, dude, I really want to answer that question before we go scraping of things around. So that's a very solvable problem, but it's something, we'll learn something there that we don't expect.
Yeah, before you send people there, you should find out whether there was life there first, because if you go and put a lot of life from Earth there, you'll just contaminate your sample selection.
It was a big deal, the Surveyor spacecraft, which are still on the moon. They brought back, was it Apollo 15? Brought back pieces of the Surveyor spacecraft. And there were things alive. I thought they survived on the moon. These things survived for 2 years. No, it turns out they're probably contaminated when they got back to Earth. It's just so easy whenever humans are involved to get living things on everything.
Thank you all. We'll take the next question.
And you are?
I'm just a regular guy, Bill Nye. So I've got a two-parter, starting with Bill Riley. So, so looking at the projection from Falcon 9, Falcon Heavy to Starship, one wonders, why not bigger? So that's part A. And part B, there are all sorts of adjacent technologies, right? And in fact, Sibley's school is really good in robotics. I think of AR, VR. I think of AI, right? The data you collect, the ability to then connect the dots to teach us about space without going there. Are those potential accelerators if we, not just focus on the current understanding of payload to colony, but thinking about how we could use adjacent fields to maybe get there faster, cheaper?
So Starship did start out as a 12-meter rocket, and we actually shrank it down to 9-meter. It was 12 meters back when it was carbon fiber, and we really wanted to be able to increase our pace of execution. And
This is the diameter.
The diameter.
Yeah,
sorry.
sorry.
Thanks, Bill. And so the 12-meter became 9-meter diameter, and you saw on my charts how we plan to stretch it. That's sort of our playbook, is we tend to stretch as we go. So I think Starship will look back on the Starships of today and say, oh, they were small, like the first ships that crossed the Atlantic now compared to super tankers in terms of size comparisons. But the size it is now is a great size because it lets us, like the places where we're launching from at Cape Canaveral eventually, and right now in South Texas, we have clears that are reasonable. We're not impacting population centers. So it's a kind of a nice size now, but it's also big enough and that we can get a lot of payload to orbit. We can launch our Starlink V2s. We can go to the moon. The scale is really helpful, especially as you look at how many flights it takes to fill it up on orbit. So I think that's why we got to the size we are today, and I expect that in time it will get bigger.
So funny thing about rockets, they have to go through the atmosphere of the Earth, and I would think that probably drives a lot of the design of what SpaceX does. In a future when you lift off of the moon, and maybe you never enter the Earth's atmosphere, what does a Starship look like? It strikes me it doesn't have to look like a rocket. It could look like a sphere. It could be shaped like a house. I mean, there's a lot of things that it could look like, and maybe there's an entirely different form of optimization that leads you to a path that doesn't look anything like the current Starship of today. And it's one of these things where I think as people looking to the future trying to figure out what's possible, we tend to lean rather heavily on what we know and what we understand. One of the things that excites me about SpaceX's work, and a lot of things I see at JPL as well, is how much freedom to innovate there is, and yet we are tightly constrained by things we've done before. Not that you are not being innovative, but if you're building a rocket that needs to take off of the Earth and then land on the moon, maybe you don't need the same thing from there to Mars. Is that possible?
That's possible. I mean, I would say that one time I was having a conversation with someone, and the question was, why is it round? And I was like, that's a great question. It's like, well, we have a pressure vessel. You basically build giant Coke cans at very high pressure, and so you end up with cylinders. And then because we're ascending through the atmosphere, we end up with pointy front ends. And so all these things kind of lead to the shapes we have. And so if you had different propellants, if you weren't storing cryogenic liquids at high pressures, if you weren't going through atmospheres, the engineering optimal would be different.
We worked on a project here at Cornell a few years ago. It was meant to be a cislunar spacecraft. And so really exciting. COVID didn't do that any favors. But one of the cool ideas there was that you can launch water as propellant, not because you can burn it, but because later on, once it's finally out of the atmosphere, you can turn it into rocket fuel, so oxygen and hydrogen. Storing oxygen and hydrogen as water avoids cryogenic storage. It's also a fairly compact way to store it. And it has the virtue that it's not under pressure, so we had a square propellant tank. And that just shocked our Air Force sponsor. So that can be done, I guess, in the right circumstances. You can avoid cylinders and circles and whatnot.
All right, maybe we'll take the next question.
I think sorry, we didn't answer the second part of the question, which is augmented reality, virtual reality going to be a efficiency increaser? I think yes. I think the videos show these amazing rocket launches, but a lot of our time as engineers are spent doing CAD. We still do, in a lot of cases, 2D drawings to communicate with machine shops. So I think all of these different things accelerating the workflow that engineers go through to go from concept to physical hardware on the production line. All these things, we've actually been able to automate a lot of it. So when we route a tube, it comes out of the tube bender without having humans create drawings. But I'm excited by a lot of these things because when it comes to turning the crank, the computer is much better at it and happier to do it and faster. And so if we can keep our focus on kind of the big picture and trying to figure out the architectures and such, these tools will help us in a big way to go faster and get this rapid iteration to be even better.
We do actually use things like AR and VR in robotic exploration. So the way that the rover planners plan where to go on Mars, they actually have these VR headsets that they use the stereo images that they take of Mars to be able to look around the terrain and figure out where to go. And they use that immersive experience to kind of plan out the drive that they would then load up to the rover to make sure it was kind of a settler, and then tell the rover go here, and then it kind of follows that path. So there's another way of using VR here to get that immersive experience to allow us to have a way of controlling the bots there as if we were there, but using the technology that's present to do it for us.
The old saying, was what our best robot does in a day, a human could do in 5 minutes, if you could get a human there. So artificial reality is the way to bridge that. I certainly hope we're doing it, because, the geologists, are there geologists here? Well, I don't know if you spent time with these people, but they think if you have a rock, you can tell who the president is, and so the whole thing is they want is mobility. They want to be able to look for a rock and then drive there, and so that's what artificial reality does, right? If it's high enough quality. So yes, of course, we're all about, what was the acronyms? AR, VR? Yeah, AR, yes, AR, VR, yes. Lead on.
All right, next question in the center.
So one question that I'm sure...
A little closer to the microphone. The microphone.
So one question that I'm sure some of the younger side of the audience is probably interested in, and don't say AI or ML. What are the skill sets that you think will be most useful for these people to learn, and that the Sibley School should foster here, such that we can help build that in the coming generations?
I would say how to solve a problem. It's not necessarily the skills, but the skill of critically thinking through a problem. Do you understand the requirements? Do you understand the constraints that you're operating? And do you know which ones to push against, which ones not to? And how do you systematically work through the design iterations buzz to get yourself to a solution to solve that problem?
And I'm such a fan of the project team experience here. I came through Formula SAE, and I felt like it was just crucial to my Cornell experience, because we got the fundamentals in class, but that's really where it cemented it into how to be an engineer. And we didn't always succeed at being a good engineer on Formula SAE all the time, but I think by the end I had an appreciation, and I really grew through that experience and through the mentorship. So I think project teams is critical. I'm so impressed with the way Cornell and Sibley School's been integrating project teams into the curriculum. Really happy to see that. But I think one of the reasons why is a lot of engineering is project management. It's working together in teams, because the problems we can solve in teams are so much bigger, and we can have a bigger impact as we approach things as teams. And so that is really one of the reasons why I think the project team experience, both in the classroom curriculum or separately through these other teams, is so important.
So you just said critical thinking. The other day, somebody asked me if somebody was going to have a superpower, a science superpower, what would it be? And the Men in Black with the flashy thing, where they can't remember the last 5 minutes. If there were a flashy thing to give people critical thinking, and that is. When we were young, what was it called? Logic or logical reasoning? Critical thinking is a fine phrase. It means to evaluate evidence. So if you get to a place in the project where it's not working, accept the fact that it's not working and try something else. So that's the nature of science. You try it, compare to what you thought would happen with what really happened, and then start over.
And it's okay to not be right?
I've spent years, most of my life, really.
You learn more from being able to understand that you're not right, and accepting and figuring out why. The why is super important to be able to go back through that critical thinking experience, be able to say, what went wrong and how can I learn from it? That's kind of the fundamental of critical thinking, not the emotion of wrong, I'm beating myself up, but what happened, what went wrong, how can I learn from it, and find a way to fix it and iterate.
And I think that's also fundamental to some of the systems engineering and product development techniques I was talking about is, we take a lot of risks at SpaceX, but we take calculated risks when it's hard to analyze. We'll go do a flight test and we'll learn. But during that suborbital campaign, I don't think I had any in the videos, but we had in 5 flights in 5 months, we had 4 fireballs and craters. And those, those were tactical decisions to fly, learn, roll it into the product, and ultimately get to a successful product faster. So I think this is actually, I think, the key skill, critical thinking.
It's interesting how classes sort of work against that, to be honest.
Yeah.
You get it wrong in class.
Thank you for your good work, Professor.
I got to say something as a Cornell guy here, right? No, but I mean, I've seen this on projects that I supervised here. The students are kind of, when they join their project, they're used to the idea that they don't dare show that they're wrong. Like somehow the process of writing homework solutions or tests is, try to fool the professor into thinking you got the answer. Maybe you smudge the text a little bit or write down some random numbers that maybe some of them are right, who knows. But that's not really helpful. And in a project environment, again, we've done plenty of projects here, you got to admit that you're wrong and then recognize it as an opportunity. So I think the only real problems we have on projects like that are when people don't admit mistakes. They just kind of bury them and then they fester and bad things happen.
Well, the problem is time. You get in a hurry. Well, that's what I've heard. I mean, not.
Thank you all. I think that's really good advice, and the faculty in the audience are listening, I'm sure. Next question with the mic.
I had a question about the immersive experience, and I think there are two kinds of immersive experiences. At least that's coming to mind now. One is a few weeks back, we were at the Hayden Planetarium in New York, and we saw this show which was basically on the solar system. It is very well done with Neil deGrasse Tyson, I think, as the narrator, and my daughter was there. She's a jaded teenager, and at the end of it, and it was going back to what we learned about the solar system, but it talks about what we are maybe about climate. It kind of alludes to climate change. And at the end of it, it was very exciting about what we have learned about the solar system. But at the end of it, my daughter said, "Oh, the Earth is very special, right?" But the other, and I think that can be used to inspire kids about science and engineering. But the other element, maybe this alludes to something we are losing. My favorite immersive experience is going to Mount Pleasant, which some of you might know, which has a beautiful view of the horizon and the sky. Most of the time when I go there, it's cloudy, but some of the times when I go there, it's very clear, and you can see the Milky Way. And I take the telescope, and when you see the Saturn's rings, that's something very special. And meteor showers, right? And then you're looking at meteor showers, and there are satellites going. and SpaceX, for instance, is going to kind of scale that up, and that really takes away from the experience. You have all these satellites going, and then there's also the light pollution. So most of the kids now, I don't know how many kids, have experienced just seeing the Milky Way and just kind of drinking it in. And I think that's something that's being lost. And if you want to comment on that.
So you're talking about all the Starlink satellites, for example. Bill?
I think the thing to know about Starlink is that there's now pretty sophisticated coatings on them so that they don't show up to the naked eye. And this is not something I work on closely, so I can't speak to it in technical depth, but I know that we were responding to some of that to make that true, that you can see the stars and you're not seeing Starlinks. But I do think the good Starlink does is pretty significant, bringing internet around the world to people in populations that don't have access to it. But I know I have a hard time getting my kids to look up off the screen and up at the Milky Way, even when we can see it. So I do think it's an important part of growing up and understanding where we are in the universe, and that appreciating that the Earth is the best spaceship I could ever imagine, and exceeding any engineering ability I think that humans will possess for more than 150 years, so we do need to take care of it.
There's a funny yet sad story that I heard that in Los Angeles in the early 90s, during the Northridge earthquake that knocked out power, they got several 911 calls about some smoke in the air or something in the air, and it wasn't going away, and they were afraid of things blowing up. And the police finally had to put out an announcement. nope, it's not smoke, it's the Milky Way. You just have never been able to see it in Los Angeles because there's so much light pollution, and it took an earthquake knocking out power to the entire grid of Los Angeles before people saw it. So this whole generation had no idea what it looked like, and it goes exactly to your point of, as we need to make sure that we understand what we're living in and what environment that is, whether it's having places on Earth where you can go and see those stuff, or being able to somehow recreate it where you have these environments. Like, I would love to have a holodeck where I could go in and just be able to get that vantage point that maybe I couldn't reach at that point, but when you experience that, like the astronauts when they first saw the Earth from space, it changed their entire perspective, right, of what it meant to be on Earth and what it meant for the fragility of Earth and the need to protect it. Those immersive experiences have a very emotional response, and that emotional response inspires, it drives innovation, it drives curiosity, and that's what we need, right? That's what we need to have more people invested in, what it means to do science and to do exploration, especially in the coming age where those opportunities are not inherently present just by looking up into the stars, into the sky.
But on the other hand, we can all look at satellite images and take them for granted. And we can all send text messages to people on the other side of the world like that. So it's good and bad. Space exploration has changed the world mostly for the unbelievably better. But I know your point of hiding the stars is bad news. You got to work on that. And all the lights that are left on at night in all those cities. Well, come on, people. Let's solve this problem. Yes, back to you.
But the views are going to be great when we're out in space
That's
exploring.
true. You ride the Starship up and you can get a great view of the Milky Way.
So, Bill, I was in Guadalajara when Elon Musk, he's the head of...
I've heard of him.
Yeah. We talked about the earthbound use of these huge rockets. London to Sydney in 45 minutes.
What we call point to
That'd just
point.
be cool as heck. Yeah.
It would be, yeah. You're basically going in a sort of orbital trajectory. So you can go anywhere on the Earth in essentially 40 minutes. And that, I didn't really talk about it today because of the kind of the time limit, but I think that's an exciting way that we could bring Starship and sort of space exploration closer to home that more people could access.
How cool would that be, people? Come on.
All right, so we're coming up to the end of our panel. I think we can take one quick question from the audience.
Well, let's get the guy in the back, too, at some point. So 2 more. Can I sell us on that?
It's up to Dave Erickson.
I know you were talking before, and someone said they didn't like the word colony for what was going to be built on Mars. So I think it was imagined to be more of a civilization. So I was just wondering if it would be integrable into like society on Earth as something like another country. Like, for example, we know that there's things like the NBA, which have like teams in Canada. So like, if there was an NBA team on the moon, would that be integrable into like modern society? And how would that affect LeBron's legacy if he played for that team? But I was just wondering more about like if like society on the Mars or the moon would be separate, or if it would be integrable into Earth as well.
I think the rules for basketball on the moon could be kind of complicated. It dribbles slower and throw farther, so I'm not sure what that means. Is the lunar team at a disadvantage when it plays away games?
Definitely. Definitely.
But I think when this settlement is built on Mars, it's going to be the way other settlements have been on Earth. They're supported by back home, and I think it would start out having a university on the moon would be great, but it's not right now. I don't think anybody sees it as self-sustaining on the moon in this example. On Mars, if you were to open the hatch, you will notice right away you can't breathe. That'll be very clear. And I don't know how much time you've spent in a middle school locker room. But when we have this big dome on Mars and then this bunch of people living in this dome, there's going to be some management issues. And then when you say, let's go outside, well, there's not really, you got to put on, you know Sandy the squirrel? You know, with her, yeah. You're going to have to wear a spacesuit to go outside. So I think it will always be an extension of some country or organization on Earth. That's not a bad thing, it's just a thing. But these are cool problems to think about. They're fantastic.
Robert Heinlein wrote a book, The Moon is a Harsh Mistress, and although you can like or dislike his politics or whatever, the story is interesting in extrapolating what a future lunar base could look like, or lunar settlement could look like. In particular, it looks at what would happen when the moon decides to revolt from the Earth. And does it follow the model of the American Revolution, for example? It's an interesting thing to look at. There's plenty of science fiction in the mid-century, last century, thinking about what that future looks like, because that was a thing on people's minds. We've kind of forgotten what maybe an earth-shattering thing it was to go to space. And now we're kind of asking those questions again, like you are.
They're kind of different camps. Like you can be on the expanse type camps where all the different settlements have their own like culture and politics, and they have their own beef with the other areas for whatever reason, because that's, you know, from things that are indigenous to that particular settlement, whether it's asteroid or Saturn or Mars, or it can be like a Star Trek camp where we're all one big, happy, united federation of planets. And I think science fiction is a great place to look at what the spectrum is, but we choose as a society which direction we want to go in, and we have to fight in order to get it to go in that direction.
Thank you all. Okay, so thanks to all of the audience for your questions. I'm going to ask one last question on behalf of the director, bringing it back to the Sibley 150. So in the next 150 years, what will surprise us? What should we start doing now, and what should we stop doing now? Don't feel like you have to answer all of those, but maybe your favorite question. But it'd be great to hear from each of you.
Oh, that's easy enough. I think dark matter will be figured out. And are there astronomers here? Yeah. Why are the galaxies moving apart? Because of something that you can't see. But I just reflect all the time. All four of my grandparents were born in the 1800s. And they didn't know there was relativity, let alone what the consequences. Like your phone depends on special and general relativity. Just think, whatever this is, somebody will understand it. And maybe there'll be a practical application that's in everybody's pocket in the next 150 years.
I think we'll be surprised by people. I'm always surprised by the creativity that comes out, especially once necessity drives innovation. So as we get closer to, you know, needing that solution for climate change immediately, or being on the precipice to be, you know, interstellar traveling, the imaginations come to light, and how that drives what people are capable of doing, I think, just skyrockets. So how they interact with each other, how they can work in teams to enable really unique aspects that I don't think we can even make connections now of, you know, we discovered how to harness solar flares to power all of Mars. Like, you know, these really kooky ideas that from now that would be like normal for them then.
Somewhere in Las Vegas or on the dark web, you can place bets, I'm sure, on where we will find life first. One of the gas giant moons, one of the so-called ocean worlds, right? Enceladus, maybe Titan, potentially, who knows what, Europa. So I'm not a scientist, and I was hoping you were going to take that one, so I can do something else. But what's your bet?
Where we'll find life? I think once we know how to look for life, like how to really look for life that's not identical to how life is here on Earth, I think we'll find it everywhere.
There's Bill's thesis, which is that maybe, I'm picking on you there, but your possibility that maybe DNA has spread throughout the solar system or throughout the galaxy.
Well, it's just if you're betting on where to find it first.
Yeah, that's the question.
It's a toss-up between Europa, moon of Jupiter with twice as much seawater as Earth, or Mars. And so there's a hypothesis now, it's very reasonable, that once life gets started, you can't kill it. And so very reasonable to me that under the salty sand of Mars near the equator, where it gets warm enough to melt water ice, there'd be something alive. That's very reasonable. But the Europa Clipper mission, the spacecraft's going to explore Europa 2033.
Launches in October.
Yeah, it launches this October. Are there Europanians
Yeah.
under the ice, swimming around? And their vision of the sky is completely different because it's all ice. Like, dude. Anyway, these are just marvelous questions. But I'll tell you, I want somebody to find life on another world while I'm still alive. That's what would you guys get that done? For crying out loud. So, Bill, we have these sample tubes on Mars. Perseverance rover driving around.
Yep.
The geologists have these sample tubes that have been left in 2 places, all over the surface and in the belly of the rover. And there's no plan right now to bring them back. No one's really.
We'll be happy
No
to pick them
agreed
up for
upon
you, though,
plan.
when we get there.
No agreed upon plan.
Well, but
I
no
think
money.
I'm pretty
No
sure they're
money.
working on it.
Yes.
So I know you guys are going to do that. So those rocks are from a river delta. So Martian rocks land here often enough. I guess Mars gets hit with something and they fall. Home in orbit, they fall here on Earth. But those are rocks that can survive the trip. We want rocks from this old mud. Yes, bring them back. Yes, that's what I'd like. But that's got to be in the next 150 years. That should be
Oh,
a
I
piece
certainly
of cake.
hope so, considering that's my job right now.
That's a piece of cake. No, 150. I think we're going to have fusion. We'll have
And I think-
earthbound fusion by then.
But for me, I think the thing that I'm excited about is I think we have collectively between all of us and kind of the state of the art together a way to get to the moon and Mars. But if I could go forward in time and see how are we going to solve certain problems, I would love to see how we're going to get out of this solar system.
Yeah.
And the creator of Star Trek, Gene Roddenberry, said, a wagon train to the stars. I have no idea there, and I would just love to check back in and see how humanity figures it out.
I'll go back to the argument about critical thinking and suggest that it'd be great in 150 years we didn't have discussions about whether or not the Earth is flat, or people who pretend that climate change is not real. That would be a nice future to live in.
All right. Well, thank you all. We'll end
Thanks,
with
you
that.
guys.
Thank you.